Hello, my name is Rajesh. We'll discuss our group discuss the multimodal emotion recognition in AI. Emotion classification. This is a standard problem in emotional AI where given input data for for a person, we try to classify the emotion of a person, like whether he is angry, fearful, or sad, or happy, or disgusted, or suppressed, etc. And different set of emotions can also be included. So, going to the introduction, this emotion recognition is basically the process of identifying a human emotion. Basically, in the during the workplaces, employees actually work better when they are happy. So, the businessmen and the managers of the workplaces, what they try to do is that know the emotions of their employees and get the data of get the data of their emotions and try to know what the situation of their company is basically, and what is the workplace of their company based on the emotions of their actual employees. So this is the fundamental research problem for the artificial intelligence research. Basically, the study shows that the technology works best if it uses the multiple modalities in context. That means that if you use different models altogether, like taking the video data, audio data, textual data all together and model each of the data individually and combine them, we'll have high accuracy levels in the final. And also there can be other psychological parameters associated along with this audio, video, and text data. So basically, the domain knowledge also plays a very key role in the emotional AI. Domain knowledge is that what is the context and situation of the emotion the person he is in. The context of situation helps in know the cultural differences of a person to person and know the emotion better. So, decades of extensive research have given numerous methods from multiple areas such as signal processing, machine learning techniques, computer vision techniques, speech processing techniques. Uh, I'll discuss one of the basic technique like the Bayesian networks model to identify the emotion. This is the probabilistic model for identifying the emotion. Now, what we try to do is that given the set of personalities of a person and given set of situations of a person, and we'll try to predict the emotion of a person depending on his personality and situation. And also we'll analyze the EEG signals of the person. EEG signals are the brain's electrical impulses when he is exhibiting the emotion. So based on these input data, we try to get the probability of each emotion of the person, and the highest high probability emotion is the actual emotion of the person in the final. This is the naive approach of the Bayesian networks. There can be other mixed models of identifying the emotion. So what we need to know is that most of the emotion recognition techniques are actually takes into account the video, audio, text altogether. So to get the more accuracy and high prediction levels. So we can classify the approaches into two types: the knowledge-based and the statistical methods-based. Knowledge-based are that using domain knowledge and semantic characteristics of an emotion. Domain knowledge is that the situation and the context of the person he is in, and also the semantic characteristics is that in which culture he is actually exhibiting the emotion from. Cultural difference has actually high impact on the emotion exhibition, as we know. And also statistical methods. Statistical methods is that we have a large data of supervised data. The data is of the form video or text or audio input data, and the output of the data is the what emotion is exhibiting, and we'll use this large data and train into a supervised learning algorithm like the computer vision algorithm, and we'll get the output for the desired input. Some of the most common knowledge-based techniques are like WordNet, ScientificNet, and ConceptNet, EmotiNet. These are all the predefined classifiers available on the internet. What they try to do is that given the text data of a person, they will try to find the relations between different words of the context and get the actual context of the emotion, and know the classification of the emotion. So these are all best used when we have large resources available for the domain specific knowledge. So these are best worked when we have large resources, large domain specific knowledge is available for that particular emotion set. Statistical approaches are like using machine learning algorithms like support vector machines, naive Bayes, maximum entropy, and also the deep learning techniques. Deep learning techniques are like LSTMs for text data, CNNs for audio, CNNs for image data, ELMs for audio signal data. When we use the statistical approach is that we use when there is a large, accurate, and unbiased data is available. From there we can get the high accuracy and predictions. So thank you.
Hello, my name is Avinash Nandyala. I am about to tell the main agenda of this AI term video. Our AI topic is recognition of emotion of a job candidate through AI, and here we are to develop a multimodal emotion recognition platform to analyze the emotion of job candidates by the interviewers. We are trying to take three inputs. One is facial means video based, and second one is vocal, that is audio based, and third one is textual, means writing the textual. We are trying to analyze these three using deep learning techniques, and this field has been rising with development of social networks that gave researchers access to vast amount of data. As I said earlier, we are trying to tell about three analysis: text analysis, audio analysis, video analysis. And moving to the next slide. And my topic is about textual analysis, and here we are trying to take the input such as answers to the questions that would be asked to a person in the interview, or in a job hiring website, or etc. And the basic pipeline of this textual analysis is, firstly we have to retrieve the data, text data from the website or something, and secondly we have to use the custom natural processing, and there are substeps like tokenization of the document, and cleaning the standardization formulas using regular expressions, and deleting the punctuation, and lowercasing the tokens, and removal of predefined stop words like and, for, and it, etc. And we have to apply the parts of speech tags on remaining tokens, and then lemmatization of tokens using parts of speech tags for more accuracy, and padding the sequences of tokens of each document to constrain the shape of the input vectors, and 300 dimension, and next step will be 300 dimension word to vector triangle embedding. And finally we have to predict using our pre-trained model. And in detailed way, the main model of this textual analysis is we have to choose a neural network based on both one-dimensional CNN and RNN. CNN plays a role of future extraction. It allows finding patterns in text data. The long-term memory cell is then used in order to leverage the sequential nature of the natural language, unlike regular neural network where inputs are assumed to be independent of each other. These architectures progressively accumulate and capture information through the sequences. And LSTM have the property of selectively remembering patterns for long durations of time. And a continuation of this algorithm, our final model consists of three consecutive blocks consisting of 4 layers: one-dimensional convolutional layer, and max pooling, spatial dropout, batch normalization. The numbers of convolution network are respectively 128, 256, and 512 for each block. Kernel size is 8, max pooling size is 2, and dropout rate is 0.3. Finally, a full connected layer of 128 nodes is added before the last classification layer. And this is the model of textual analysis. Thank you.
Hello, this is Tejendhar. I am going to discuss about classification of emotions on a video. We know challenges such as emotion recognition can typically not solved with classical machine learning techniques. So we classify these using CNNs, and so over here our first basic pipeline is we will switch on a webcam, and we will record the video, and we will break it down into many images, and later we will apply grayscale filter to filter few inputs, and we will identify the face by zooming on it and make the dimension of the image 48 into 48 pixels. And also we need to manage multiple faces at a time, and transform the input into model readable input, and predict the emotion of the, and then we will predict the emotion of the input. And here basically our model we have chosen is exception model. In this model basically this model basically gives a very good validation accuracy and training accuracy. Basically, first, what we don't know whether there is an imbalance in our input image set or not. So first, we will use this data augmentation so that we can so that we can increase the number of images artificially, and then like similarly we will add many of these we'll choose many of these with our exception model, such as auto-regularization for to decrease this overfitting, and also weight balancing of classes and everything. So basically we are using classification of emotions. So we use labeling as 0 for angry, 1 for sad, in that sense. And basically this architecture is based on depth-based convolutions. So what's happening here is basically what we are mainly trying to do is to decrease the number of parameters, so that the computation efficiency will increase. And at each convolution step, for each input, we apply an activation function, typically ReLU. To reduce the dimension, we then apply a pooling step. Pooling involves a downsampling of features, so that we need to learn less parameters when training. The most common form of pooling is max pooling. The intuition is that max pooling has higher chances to be more significant when classifying an image. And yeah, we will take our initial data set, and we will label our every input image, and then we will basically find our accuracy and everything. And our method, and what basically we are doing is we are applying CNN in real life is actually a great challenge. And we are actually we have plotted here the activation map, where we can see that in happy label we can see that more contribution is from mouth part and eyes part. And similarly for anger and sadness, we can see that its respect to activation areas. So by using these, we can see that we can predict whether an image is sad or happy. So by using this exception model and adding these tuning methods, we are getting nearly 70% to 75% of accuracy. And for our final methodology of this is basically we have labeled our video. Video has basically three parts: the text, maybe the text, and voice and images. So we will use these three, and we will use these ensemble techniques and find the probability that the given image is happy, or at a given point the video is happy or fear or disgust, and or like that. And then we will finally predict the value of the label of our model. Thank you. And from
Hello, I'm Bhanuteja. I'm going to discuss about the audio analysis of this presentation. Now, speech emotion recognition purpose is to automatically identify the emotional or physical state of a human being from his voice. The emotional state of a person hidden in his speech is an important factor of human communication and interaction, as it provides feedbacks in communication while not altering linguistic contents. Speech emotion recognition is based on discrete emotion classification system. In most cases, literature focuses only on 6 emotion labels, which are happy, sad, angry, disgusted, fear, and surprise. Although there are many more complex emotions in real life, we are going to consider only these emotions. The usual process for speech emotion recognition consists of three parts: signal processing, feature extraction, and classification. Signal processing applies acoustic filter on original audio signals and splits it into meaningful units. Next, the feature extraction is the sensitive point in speech emotion recognition because features need to both efficiently characterize the emotional content of a human speech and not depend on the lexical content or even the speaker. Finally, emotion classification will map feature matrix to condition labels. Now here in this here we are going to take the input as the voice recordings from job interviews for speech emotion capture. Speeches include calm, happy, sad, angry, fearful, surprise, disgust, and expressions. And also we take some songs also like speech. Now the basic pipeline for this is voice recording. First we will record the voice, and next audio signal discretization. In this we will sample our signal and change it from continuous time to discrete time. Next we are going to do the log-mel spectrogram extraction. Here we are going to use Mel scale. Mel scale is a perceptual scale of pitches judged by listeners to be equal in distance from one another. The reference point between the scale and the frequency is defined by assigning a perceptual pitch of 1000 mils to a 1000 H tone, 40 decibels above the listener's threshold. Here we just convert heads to mils. Now after we did this, we'll split the spectrogram using a rolling window, and then we will make a prediction using our pre-trained model. Now let's discuss about this model we are going to use. Here the model we have chosen is a time distributed convolution neural network, and the main idea of time distributed convolution neural network is to apply a rolling window which is a fixed size and time step all along the log-mel spectrogram. Means we will traverse the log-mel spectrogram using this rolling window. Each of these windows will be the entry of a convolution neural network composed by 4 local feature learning blocks, which are called LFLBs, and the output of each of these convolution neural networks will be fed into a recurrent neural network composed by 2 cells, LSTM, which means long short term memory, to learn the long term contextual dependencies. Finally, a fully connected layer with softmax activation is used to predict the emotion detected in the voice. And after we did this to limit the overfitting, means to not make the model too much fit into the training data. We tune the model with various things like audio data augmentation, early stopping, and kept the best model. Thank you.
Final phase of combining everything which we got from different analysis, right? So we analyzed video from which we got facial features, and from audio we converted that audio to text, and then we performed textual analysis. So after combining these different analysis, we get our final reports of the emotion the audience is trying to convey, right? Now let's move on to the final phase where I'll try to tell you what our conclusions are. Now, some of the things that AI struggles with is understanding nuances, like detecting and decoding emotional subtleties based on social cues, creating original content, and without a large set of data and defined parameters. And filtering biases is one of the important ones, and identifying biases based on social or ethical consciousness is one of the other things that AI really struggles with. And in conclusion, other than the proposed approaches in the introduction, there are also different other types of approaches where there is use of domain knowledge and supervised data. Text data is favorable research object for emotional recognition because the storage of text data is lighter and easy to compress, right? And let's talk about some of the limitations of AI. Now, the risk of bias in emotional AI is because this is important because AI is trained upon the examples which we give, and bias can be easily picked up from that, right? And because of subjective nature of emotions, emotional AI is prone to bias. Um, a study found that recent emotion recognition techniques assigns more negativity to certain ethnicities. And AI is also not sophisticated enough to understand the cultural differences in expressing and reading emotions. For instance, a smile might mean one thing in Germany and another in Japan, right? So to avoid bias, different methodologies are employed. And implementing neuroscience technologies such as facial encoding biometrics resulted in 62% accuracy. And when combined, accuracy actually raised to 77%. So in total, emotional AI will be powerful tool indeed, forcing businesses to reconsider their relationships between with consumers and employers alike. And let's talk about benefits right now. Okay, so the first undoubted benefit of AI is because it's software, it's cheap and can be deployed anywhere with an actual computer. You don't need experts to execute the functionalities or tasks, right? And some people out there, male and female, struggle greatly with relationships and struggle to find that connection. And why is that connection so important? Because for us humans, it is important when someone remembers that important day or asks us how our day was. And AI doing this actually generates a feeling, oh, it remembers and it cares. And there are already so many areas where we cannot distinguish AI with human. For example, Xiaoice. Xiaoice is the softbot that Microsoft has in China that is used by over 100 million people. Basically, it has an emotional interaction with the user, and the users get hooked. So she has this persona of a teenage girl, and sometimes she shows you sympathy, and sometimes she gives you a hard time, and people really get attached to this softbot, and the users actually love her. So these kinds of technologies actually fill the gap when another human isn't present there. And also, there's a study done at a university, USC, where they looked at PTSD patients. They had some of the patients interview with an actual doctor, and some of them were interviewed by an AI avatar, right? And they found that the patients were actually more open and forthcoming when with the avatar than with actual doctor, because it was perceived to be less judgmental. Only 10% of the signal which we use to communicate with one another is the choice of words we use, and 90% is non-verbal. You can understand how important it is to understand and analyze non-verbal communication also. About half of non-verbal communications is facial expressions, your use of gestures, and I think at some point we start to look at AI-driven devices and robots. Okay, I think at some point we look at AI-driven devices more like people rather than devices itself. People are actually testing the boundaries of human-robot interaction and what we value in relationships. Questions like, is companionship better than no companionship at all? Or is there no substitute for the human factor? These are really important questions, and we hope we can answer this with AI. And that's it. Thank you.